Fractions and mixed numbers. Let's talk about fractions first. Whenever I talk about a fraction, we're talking about a part of a whole. And whenever we talk about parts of a whole, we come up with this format. We have some number divided by a number, or it could be written this way as well. Or it could be written like this. However, the denominator is the bottom number, and that is the total. That's the whole. So like if we're talking about a part of a pizza, then the bottom number will be the whole pizza, and the top number will be the pieces that we take from it or we leave behind, whichever one it may be. So in example 1 here, we have these three examples here showing you parts of a fraction. So on this first one here, it says, what fraction of this circle is shaded in blue? So what we need to do is count all the pieces. 1, 2, 3, 4, 5 pieces. So we have 5 total. And then what part are shaded in blue? Well, we wasn't specific if it was dark blue or light blue, but so if we're going to count both of these pieces, one's dark, one's light, we're going to say 2 out of 5. If they said light blue, then we'd say 1 out of 5. If they said dark blue, we'd say 1 out of 5. The next one says what fraction of it is gray. So we have this one here that's gray. So I have 1 out of 5. So 1/5 of this diagram here, this picture image, is 1/5 of it is gray. Oh, and then it said not gray. So let's check not gray. So that means that leaves us with 4 pieces that's not gray out of 5. This next example says what fraction of the pizza is missing? Well, I have 2 pieces here that's missing out of 3, 4, 5, 6, 7, 8. So I have 2 out of 8 that's missing. That is a correct statement. Of course, your final answer will be written in reduced form. It'd be 1 out of 4 because 2 goes in itself once, goes in 8 4 times. So 1/4 of it's missing. The first example did not reduce, so I left it in that format. Now, this next question says, what fraction of the pizza remains? Well, that means I have 6/8 of it remaining, and let's reduce it. 6 reduces by 2. 2 goes into 6. Let me just write it like this. 2 times 3 is 6. 2 times 4 is 8, and I can reduce it by 2, and leaves me 3/4 of it remains. Now let's look at this final one. If we wanted to represent the pieces of the box shown above as a fraction, what number would be used as the denominator? So the denominator, remember, is that total. So I'm going to go 1, 2, 3, 4, 5, 6, 7. So my denominator would be 7 because there's a 7 total pieces here. Let's go to our next one. The next one's talking about proper, improper, and mixed numbers. So I'm just going to jump here. I'll let you read up on it as much as you need to. So this first example here says change the following mixed numbers to improper. So let's talk just a second about mixed numbers. Mixed number is a whole number times a proper fraction. What is a proper fraction? Hopefully you've read that above. Proper fraction is the smaller number over a larger number, and it's in reduced form always. So we have a whole number times a proper fraction. That gives me my mixed number. An improper fraction is going to be a larger number over the smaller number. What does not change is the denominator. So if I wanted to, I could just come across here and go ahead and write the denominator down on all these examples because they don't change. What's going to change is our numerator, and this is the process. We say the denominator times this whole number. So I got 4 times 5 gives me 20. And then we're going to add it to that numerator. So 20 plus 3 gives me 23. That's my new numerator. And now this is written as an improper fraction. If you can reduce, always reduce. Okay. So let's do this next one. 7 times 1 is 7 plus 1 is 8. So there's my improper fraction. 3 times 8 is 24. right? 3 times 8 is 24. Plus, I'm going to add that 2, and it gives me 26. Does this reduce? Well, we can always check to make sure it reduces or it doesn't, because you always want to put it in simplest form. But in this case here, 2 is made up of 2 times 13. 26 is made up of 2 times 13. Therefore, it does not reduce because 3 does not reduce with 13 or 2. All right, so let's do our next set of examples. Again, I could just come across here and say, oh, okay, the denominators don't change. I can go ahead and do that. Next, I could say, okay, 5 times 15. So 5 times 5 is 25, carry the 2. 5 times 1 is 5 plus 2, 75. And then I'm going to add this 2 to it. So I got 77 over 5. Let's do this next one. This next one is 17 times 10. So I got 7 times 0 is 0. 7 times 1 is 7. And then I'm starting in this next column, so I put 0 right here and move over. So 1 times 0 is 0. 1 times 1 is 1. So I got 170. And then I'm going to add that 11 to it. So I get 181. It does not reduce. That's my simplest form. Okay, so this next one, I'm going to say 35 times 7. 7 times 5 is 35. Carry the 3. 7 times 3 is 21 plus 3. That's 24. So 245. Oh, what did I not do? I didn't add my 21. So let's add 21 to this. And if you're ever in doubt, check your work. It's always good to know how to do this without a calculator, but it doesn't hurt to double check if you're ever in doubt. This will help also boost your confidence when you realize, hey, I was right. Okay. Now, let's take this improper fraction. Remember, improper is larger number over smaller number. So let's take the improper fraction and convert it to a mixed number. And if you can reduce, always reduce. So what don't change? The denominator. And to find this missing piece, the missing whole number and the missing numerator, I need to say, okay, the denominator times what? And then I'm going to add it to what? Okay, so first things first. The denominator is 5 here, and I need to multiply it to what to get close to 13? Well, I know 2 times 5 is 10, so I'm going to say 2 here. And then I'm going to take that 13 and I'm going to subtract 10 from it, and that remainder is what goes here in the numerator. That's one way to find our answer. I'm going to use a different way to find this answer, okay? So, denominator don't change. Long division. So you can use whichever method works for you, okay? I'm just going to show 2 different ways just in case you want to do it this way. Now, the bottom number always goes on the outside, and the top number always goes on the inside of long division. We ask ourselves, how many times will 12 go into 17? Go into it once. 1 times 12 is 12. 17 minus 12 leaves me with 5. All right, so this number here is my whole number, and this is my new numerator. And now I got my next number. So you could do either method. It's fine. Doesn't matter to me. I'm going to switch back and forth just in case you want to. Okay, so 35 is my denominator, doesn't change. So what I need to do is figure out 35 times what will get me close to that 17. Well, I know, let's do 35 times 3. Because I know that 35 plus 35, right, will give me 70. So that happens twice. So to not completely go over 100, what if I said 35 times 3, which it might bring us over that. So 3 times 5 is 15, carry the 1. 3 times 3 is 9 plus 1. Barely went over, but that is correct. We wouldn't want a bus because the bus would go over that numerator. So 35 times 3 gives me 105. So if I take that 117 and subtract that 105, what do I get? So 7 minus 5 is 2, 1 minus 0 is 1, and then 1 minus 1 is 0. So 12 doesn't reduce. So that is my final answer. All right. I want you to do D through F and ask me during class. Or you can set up an appointment if you need to talk about it. Let's move on. Okay, so now we need to determine what type of fraction this is. Okay, so a note. Anytime 0 is in the numerator, doesn't matter what's in the denominator. Anytime 0 is in the numerator, the answer is always 0. Anytime 0 is in the denominator, no matter what's in the numerator, anytime 0 is in the denominator, this is undefined. So A is 0. D is undefined, or excuse me, B. C is 0. Reading and measurement. I know this is just a little blurry and I apologize for that. So A says the dark blue. So we are looking at this right here. And it shows to be just a little over an inch. 1, 2, 3, 4. So actually, if this will help you go count out how many's between each one. So from 0 to 1, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 spaces, right? So I'm going to go ahead and put my whole number down as 1. And then I got 1, 2, 3, 4, 4 16ths. Of course, this would not be my final answer. I'd say 1 and reduce that 4 16, which gives me 1/4. Okay, so show both steps. Okay, what measurement does the red line represent? So here we go. Our whole number is 4, and we scooted over 1, 2, 3, 4, 5, 6, 6 16ths. This will reduce by 2. 2 goes into 6 3 times. 2 goes into 16 8 times. So there's our answer. I want you to try C and D and just reach back out to me. And then our last ones. Let's do one of these applications. If you have $12 and you spend $7 on lunch, a sandwich, drink, and chips, what fraction of the money did you spend? Remember, your total is the denominator. So I had $12. I spent 7. So my fraction is 7/12. Okay. Let's go ahead and do B. A typical dose of children's Tylenol contains 200 milligrams of medication per teaspoon. How many milligrams excuse me, guys, I read that question wrong. Each 80 milligrams is what part of the typical dose? So we have a total of 200 and we have 80 as our part. So let's do this. It reduces, we know that 80 will and 20 will reduce by, let's say 40. So 20 reduce, let's do 20. Let's start with 20. 200 reduces by 20 10 times. So I'm going to say 10 times 20. And 80 reduces by 20 4 times. So I'm going to say 4 times 20. My 20s reduce, leaves me with 4/10, which reduces 2 times 2 over 2 times 5. 2's reduced, leave me with 2/5. And that's my answer. So try C and then just read back out to me. Thank you.